Hello everyone from the world of industrial automation. My name is Artem Melnik. I am a software engineer with 15 years of experience in developing firmware and software for programmable logic controllers, as well as integrating CODESYS runtime into this firmware. Today, I'm launching the first season of the engineering series Mars Colony 2.0. Elon Musk's vision is to create a self-sustaining civilization with a population of 1 million people on Mars, capable of existing independently from Earth. This isn't just a base, but a full-fledged colony with its own economy, manufacturing, and government. Let's break down the plan for colonizing Mars into 4 stages. Stage 1 is the arrival of the first unmanned ships with robots. The tasks: deploying solar panels, energy storage systems, and distributing power to consumers. The second stage is building a methane production plant, storage systems, fuel distribution, and transportation to consumers, as well as a system for refueling ships and preparing them for launch and landing. The third stage is constructing a minimal life support system for the first humans. And finally, the fourth stage is the arrival of the first humans at the already prepared base. Our channel has the exclusive right to offer a promo code for a 35% discount on the SPC210 and input-output modules from akYtec. I will provide all the CODESYS projects used on our channel for free. We'll use a simple and easy-to-understand 3-level model of an automated control system. The complete list of subsystems in the automated control system for the Mars base includes the central control system, which handles global optimization, planning, predictive analytics, and coordination of all subsystems. Second is the energy system: solar panels, batteries, backup generators, distribution network, and the management of energy generation, storage, and distribution. The third system is the methane production system. This includes water extraction, electrolysis, Sabatier reactors, purification, and liquefaction of methane and oxygen. The sixth system is the refueling and ground operation system. This covers refueling spacecraft and preparing for launch and landing. Seventh is the life support system: air and water regeneration, food production, atmosphere control, radiation protection, and thermal control. Ninth is the robotics and autonomous machine system, such as humanoid robots, rovers, and construction equipment, whose tasks include navigation and infrastructure maintenance. The 13th system is the health and environmental monitoring system. This includes medical monitoring of the colonists, radiation control, dust and seismic monitoring, and gravity normalization, which is an extremely important factor for human health and reproduction, since gravity on Mars is 2.5 times weaker than on Earth. The 15th subsystem is the maintenance and predictive analytics system. This can include equipment condition monitoring, repair scheduling, and predicting breakdowns using artificial intelligence. In the next videos, we'll take a deep dive into the most important system: energy, from solar panels to energy distribution. Let's highlight the very first key tasks of this system. First, we provide the main electricity generation using solar panels, then we store the electricity that has already been produced, and after that, we distribute the electricity to consumers. Let's visualize the main tasks of the solar energy management system. The first task is that the system must calculate the electricity generation from the solar panels. Simply put, it needs to determine the amount of energy produced. The second task is that the system must manage the charging and discharging of the battery. Simply put, it decides where to send excess energy and where to get the missing energy from. The third task is that the system must manage the distribution of available electrical energy among consumers. In simple terms, it decides which consumer should receive this energy. Let's break down each of these tasks into 3 steps in more detail. The first task is to receive data from the sensors: the amount of sunlight hitting the panels and the temperature of the panels themselves. Second, you need to take into account the efficiency coefficient and the area of the panels, as well as the temperature correction, since the efficiency drops when the panels heat up. And finally, based on this data, calculate how much electricity the panels are generating right now and provide the result, the efficiency coefficient of the panels and the current generated power. And the second task is to accept input data such as the battery voltage and current, the current battery charge level, the battery temperature, the current generated power, the amount of energy required by consumers, as well as forced commands for charging and discharging the battery. It is also necessary to take into account the battery charge level and its temperature. For example, you cannot charge above 95% and you cannot discharge below 15%. If the temperature exceeds 45 degrees, the battery operation must be completely blocked. And based on this data, it is necessary to decide whether to charge or discharge the battery, or do nothing, as well as whether charging or discharging is allowed, the battery's power, and its current charge level. And the third task is to determine how much total energy is available, solar plus batteries, how much energy each consumer is requesting, taking into account the priority of each consumer's importance. It is also necessary to take restrictions into account. You cannot give a consumer more energy than they requested, considering their priority of importance. First, we give energy to those who need it most, and based on this data, we need to decide whether to give the consumer the requested energy or not. It is also necessary to distribute the energy among the consumers according to their importance and provide the result. How much energy each consumer received, and how much energy remains undistributed. We have defined the tasks for the solar energy management system. Now let's design the main page of the user interface for this management system. In the first stage, we will add only the minimum number of elements needed for data monitoring. First is the efficiency coefficient of the panels. Second is the power generated by the panels. Third is the battery charge level. Fourth is the charging or discharging power of the battery, their maximum and current capacity. Fifth is the amount of energy received by each consumer. Sixth is the remaining available power. And seventh is the power generated by each unique panel array and their operational status. In the next videos, we will follow this plan. First, we will create a web visualization using the built-in tools of the SPC210 Linux controller from akYtec. That means we will use tools like Python, HTML, and JavaScript to add interactivity to the user interface. In other words, to make it dynamic and lively. Next, using CODESYS, we will create a solar power management algorithm, and with the help of built-in inter-process communication mechanisms, both in CODESYS and Linux, we will transfer data between the main CODESYS task and the web visualization task implemented in Python. As needed, we will also add monitoring and control elements to the web visualization project. Friends, an important point. If you are watching my video in your native language, be sure to re-watch them on the CODESYS_akYtec_en channel. Why? First, all up-to-date modern technical documentation is written in English. Second, re-watching the same material in English is one of the fastest and most effective ways to improve your technical English. So subscribe to my English version of the channel, CODESYS_akYtec_en, and rewatch the videos there. Our channel has the exclusive right to offer a 35% discount promo code for the SPC210 and akYtec input-output modules. To get this promo code, all you need to do is send a personal message with the text promo code to any of my contacts, melnikartem@gmail.com, WhatsApp or Telegram at the phone number +1 904 505 6665, and I'll send you the 35% discount promo code in a reply to your message. You need to apply it to your cart in the special promo code field. There's another nice surprise for those viewers who purchase the SPC210 and send me the device's serial number in a private message. I will provide all the CODESYS projects used on our channel for free. And don't forget to subscribe to our YouTube channel so you don't miss the next videos. And give this video a like if you enjoyed it. That's all for now. See you in the next video.